Hello guys. So on today's video we are going to discuss about a question which is about a power of two number using iterative method and recursive method. So first of all we are going to discuss a power of two number using recursive method. Just like my question is, if the two number is given to you, just like uh, 3 is equal to a, and you need to calculate the power times 15. So how you can, so for calculating this, if you think you can use a for loop like start from I equal to 0 and run for 15 times, and for each time you just do, and on each time you just multiplies 3 for 15 times. So think about yourself, is this a good approach or is this a correct approach or not? The time complexity will be big of n, but if you are do this using recursive method or iterative method, then it will be managed using a big of log n or log p times. So let's do this, how we can do. So the number is 3 to the power 15. So the first approach is a recursive approach. As a recursive approach says, so think about it, it is a multiplies by 15. So if we somehow breaks the 15 in such a form like 3, and the 15 represented by a in a binary number as 15, right, so 15, okay. So it can be written as 3 into 3 as comes, and after after keeping 3 away, their character will be becomes 3 to the power 14 as it is. So we can write as 3 to the power 14, and we can also write as this is equal to 3 into 3 to the power 7 plus 3 to the power 7. So what we are observed, it will gives the same result. So when our number is the power of number is odd, we just grab the first element and doing the multiplication of other two recursively divided their half numbers. So as if our number is even, let's suppose our target is 3 to the power 16, then I can write as this is equal to 3 to the power 8 plus 3 to the power 8. What it represents? It represents the same as this. So this is our idea to divide particular power numbers into two subset if it is even, and when it is odd, I just says grab the first number and do the and make it is as even, and after making it is even, divide their power into two parts. So if we and recursively do the operations till you got the particular power. So if we try to write their function, so I can say here the function for the odd number will comes as, the function for the odd is says when I do the OR operation between a to the a and b, the recursive functions take the number a and do the multiples of with the each time divided by their real multiples n. So what it could be, it is, let's suppose I already stores it into a something called result, which already stores your b by 2 for each times, and a into, I can say I just grab the result in this time, and it will shows the result as you say. So, and for the case of event, I just says call me your function a into recursively divide our number. So it will be a the function name again. I can say recursively result, which already holded the data for the multiplication of recursively divided number of multiples. So as we comes on to a code part, then we can say first I need an increment function. In increment function, this is our target is equal to calling the function. How we can call the function? The first thing I need to make a target is to be just like a power of recursive function, and this have two parameter int a and int b. A is the number, b is the value of power of that number. So if so, what is our target? Our target is to find the recursive function of a into b into result. So for recursively dividing the b number, I made a variable result which takes the which calls the for recursive function, and what it do? You just take divide the your power by 2 on each quadrant. As you see, if it is even, and it just divide the number by 2, and okay, it is capture, it be a capture. Okay. So after calling the function, so I did a mistake here, the y function will be a int function. So now so the result variable are made which holds the recursively divided value of the particular number. So after this, what would be our next step? Our next step is, now we recursively find, we need to define a recursive function for both cases, odd and even. So for checking the number odd and even, just like number is 15, then we know their zeroth bit is 1. So we can say if their and with the particular number is comes to be 1, then it must be a odd number. As you already know, the odd the zeroth bit of odd number is 1. So I can say uh, b and b with 1. If b of and with 1 is 1, then just call the function, then return our function what it is, and return our function, the put the value is of, call the value a and b by 2, a result into result. Okay. a of that number into result into result. Okay, so after finding the result, and otherwise when it is even, just return the call function. The call function just return the value of a multiplies with, just return the base, just give me the divided, just give me the corresponding divided multiples by two numbers. Okay, the power, the corresponded power divided by, divided into half, just give me the result of the corresponding power, this is into half. So I save this, it will be a result. After finding, I can say it man, I run function with man, and please int a is, I have a, and b is equal to 5, just call my function, and in a function please give my value. Okay, as if you want to see. No declared here int. So if we run this, and you can see what the result is. So okay, so if you talk about compiler will run, so as you can see, the code doesn't print anything. Do you know why? Because the code is doesn't print anything, because we have some missing element, which is our base case. We are written all of the code, this is all truly, but we are just miss the base case. When you are dividing the number by 2 again and again, now 3 by 8 is converted again into a 3 by 4 into 3 by 4, and 3 by 4 again converted into 3 by 2, 3 by 2. So there is a time comes when it becomes 0. So at the time when it becomes 0, then how you can deal with the condition? So we need to make, when the condition becomes 0, just 3 deposits, like 3 deposit 0 becomes 0, then just print 1. So if the some condition comes when d becomes 0, then for that condition return 1. That condition return 1. So our idea is pretty simple. So now we can see our code will run or not. So okay, let's return 1 to check it again, and then we can approach to our using recursion method. So the code will run. If I say I have number 2 and I want power with 5, so you can see the number is 32. So there is an if you are direct using this number, then it can cause an overflow issues for for longer in integer. Just like if I say if you are using this condition, then it can become problematic for large overflow conditions. Just like, so for handling with large integers, just it calls the functions again and again. So for large numbers, it makes call. So for treating with large numbers, just uh, you can make the result variable as long, or you can make uh, or by typing onto a ll you can convert it into a long. So from now it also handles the long integers, or you can change into a variable. Both condition will works. So as of now, when I run it, equation is so. Let's start handling the condition. If we are talking about the time complexity and the space complexity, so the time complexity and the space complexity will be, what will be, the time complexity will be big of 1. It recursively call the stack for the size of b, so their time complexity will be big of log b. Time complexity will be big of log b. And if we talk about their so we are come on to our next step using recursive approach. So the number is, let's suppose we are going to take the same example, 3 to the power 15. So recursive approach are doing using a bit masking. Are you ever read about bit masking? I says the 15 is represented in a binary number as 15 can be represented in a binary number as, so the binary representation of 50 number is 1111. So I can say in this time, if y, so let's take the binary representation of every stated bit are converted into a multiples of 2 into the power of 2, then we can get the particular number of 15 is power. Okay, so it is like, if I capturing the zeroth bit, capturing the zeroth bit for all the iterations, for all the numbers, capturing the zero bit and do their to the and converted into the combinational power, and for each times we do the left shift the bit for one times and we do again the power with 2. So for this we can get the number. This is in properties of binary search, properties of bit. You can if you are read, then you are know. So I can say the one, it could be represented as to the power 1. For the zeroth bit, I can say for for every stated bit, take the for every stated bit multiplies do the power of that current position numbers. And if unstated bit is comes, let's suppose there is an binary number of 3 to the power 13, whose binary number is 1101. When unstated bits comes, then don't do anything, then don't count that the multiples up to the power and sum. So in this time, what is the result? I says the 15. If we calculated the 3 to the power 15, there were three things. At the first time, this is 1 1, and here is A, here is ANS, here is answer response after this. At first, I am at 0th bit, then I just do the here to the power, so the answer will be 2. And on for next time, I left shift the bit for one position, so now it becomes the triple one, and we are, I am at the 0th position, and I do just, and I do the combinational multiple sum, consecutive multiple, so it becomes to the power 2. On each time, as we are dividing, so we are multiplying the a for their n time, so it now it becomes to the power 2, and answer will becomes, so in answer the current answer will be multiplied, because We, as on earlier, we know that 3 to the power 15 displayed as displayed as 3 to the power 2. 3 in 3 to the power 15 can be displayed as 3 into 3 to power 3 to power 14, and it could be displayed as 3 into 3 to the power 7 into 3 to the power 7, and it is keep dividing. So you can say a is consecutively multiplying with the number till it becomes 0. So now a is again multiplying between the insert, and we did a combinational sum, so we are adding a is multiplying with a, and doing the combinational sums it again becomes to the power 3, because we are also adding the insert with this combinational sum. So we again doing the left shift of the bit, and now it becomes 1. So it's again do the multiples of, now it becomes to the power 4. So it's kept dividing by 2, so it's kept multiplying. So now it's again 8 into ns. So in this time is 3, so it becomes to the power 7, and it's again 1 at 0 bit after shifting right shift, so it becomes to the power 6, and is added, so it becomes to the power 13. As you can observe, using right shifting of the bit for n times, for every times if we multiplying this every single number power, so we can get the multiplication of that number. So what will be our iterative method? So it's a iterative method. The before which we are explained is a recursive method, so it's a iterative method. So we are just iterate a left shift for each position. So if we come on to our code, it is calculating using iterative method. Okay, using iterative method. So if we come on to our code for iterative method, we just do the some changes into our previous recursive approach. What type of changes we are doing? Let's see. The results are calculated. We need to receive the bill. So I says remove the whole thing and just check. At first, our answer will be our answer will be 1. As you can see, the answer will be upgraded with the comparison with the 0th bit for every sequence of bit will consider. So at first the answer will be 1, and as you can see, we need to first check the current number is odd or even. So I am just saying, if the current number is odd, so there and with 1, we need to check the setted bit. For every setted bit, we are creating the multiples. For every setted bit, we are controlling we are converting their 0 bit position to the power n, and where the current position is changing between the n number. So if the current bit is setted, then just multiply by answer by the current number. Just in this time it will be 2, and on next time it becomes to the power 2. Just like in this time, if you are calculating for that number, you are already read, if you are reading carefully, then it becomes to the power 0 at this time, or zeroth number. It becomes to the power 0, or zeroth bit is of every single bit is a multiples of the to the power n bits. You are, if you are learn carefully, then you are knowing about this. Okay, so if the current bit is n, of there is stated bit, and return the multiples of their bit will be, then upgrade a with, a with the multiplication of, upgrade answer with multiply a within it. Okay, you can also be in the modulo for preventing from overflow condition. So I can say I want to overflow condition. Okay, if the setted bit is not setted, then there is no condition, because it says long am. So I am forget about to initialize long am. We can say long am is a long number, which is only 9 plus 7.
Okay.
So long am is created. As you know, m is represented like, m is a large number. If you do modulo with a large number, then the value reserved is previous number as it is. Just like if I do, you do, and also you, if you watch carefully, a is also squared onto is on each every iteration. So a is successively squared on each iteration. So it is like a is e into a. Okay, a becomes a into a. It's like if you, or whenever you are dividing any number, like the number is 4, at first what you are doing, the number is just like a 14. So first you are dividing into a 2 part to the power 7, then you again divide into half to the power 3. So the same things is doing into a recursive step, so iterative step. So multiplying onto a back side is a backwards also. So successively squaring the a, or handling with the large input integers, modulo m becomes necessary inside. So for preventing the overflow condition, modulo m is a very crucial and important step that we can consider. So as you can see, the thing will show the proper output or not. So we need to comment it out first. Okay, the function can be run, so which we also need to comment it out. So now it will run, as you can see, right comes 4. Okay, we need to check. So there were some conditions. We are checking for every single bit, and the left shift will be considered for each bit. So the condition should here will be, while b is checked for each condition, the right shift will be made. Okay, it's just shift the bit for You just shift the beat to the left for one to the right for one position. It will create the beat to the power n terms. So 0 with n. Shift the one beat. Shift the beat for the one. So left shift the beat for the one. So as you can see, the answer should be 256. Why it comes 256? We need to analyze it. So at first recursion, it will multiply the number with a. So our recursion at this time is answer is 2 and it multiplies with the 2. So at this time it becomes 2 and the answer is 2. And after we put it together, 3, 4, that's the top. So we put it down. For printing result, the return function is essential, which is cleanness, and let's see whether it works or not. We need to check for the D number. By mistakenly I just tried to the A numbers, but it is B number. So as we can run, I think it should be run now. Yes, it will be run. Okay. So that's for today, guys. If you talk about their time complexity, each loops is run for their depth of the B. This is B log we have the same, but it is the iterative method in which I will just save the beat for every single beat and creating their to the power n times. So this is our approach. If you want to stay connected with me, so please subscribe our channel